Welcome to the deep dive where we really try to get to the heart of the big topics shaping our world. And just before we jump in, we need to give you this important disclaimer. This episode of the AI Daily Deep Dive podcast was researched entirely by the AI model ChatGPT o3 Deep Research and is fully AI generated. So today we're tackling something that honestly feels like it's ripped from science fiction, but it's becoming very real, very fast. AI improving itself. We've all seen AI do incredible things lately, right? Mastering tasks, beating humans at complex games, but what happens when AI starts refining its own code, optimizing its own algorithms, maybe even dreaming up new ways to think, all without us looking over its shoulder constantly? That's the core idea behind concepts like the intelligence explosion or the technological singularity. How? So our mission today is to, pull back the curtain a bit. What are the first signs of self-improving AI? How good is AI already at doing AI research itself? Where do we humans still have an edge? And then looking ahead, well, how long until AI might go fully autonomous? And what would that actually mean for all of us?
It's a really fascinating and maybe slightly unnerving thought, isn't it? This idea of a virtuous cycle, as some call it. Accelerating improvement, where the machine itself drives the next leap forward. It sort of hints at a future where progress isn't really bottlenecked by human thinking speed anymore. And the implications, as our research shows, are just profound. Moving AI from just a tool, however powerful, to potentially an innovator.
Okay, so this idea of AI improving itself, it sounds huge, but are we seeing actual concrete examples of this right now? What does it look like, on the ground?
Oh, absolutely. We're seeing some really significant, though often quite specialized
Yeah.
example. Think about self-playing games. DeepMind's AlphaZero is maybe the classic case here.
Right, the Go program.
Exactly. But the key thing about Zero was, unlike earlier versions, it started with nothing except the basic rules of Go. No human expert games to study.
Nothing, just the rules.
Just the rules.
Yeah.
It essentially became its own opponent, its own teacher, played millions and millions of games against itself. And in doing so, it didn't just learn Go. It rapidly blew past all human champions. AlphaZero then did something similar for chess and shogi. It wasn't just learning existing strategies. It was discovering, kind of reinventing centuries of human strategic thought in just days or weeks.
So it wasn't just copying, it was creating new ways to play.
Precisely. It was autonomous discovery and optimization of strategy, a really powerful demonstration. Then you've got automated machine learning, AutoML, basically AI designing other AI.
Okay.
Google's work here, like NASNet, was a big deal. They had a sort of controller,
Right.
AI generate potential neural network designs, test them, and learn from the results to propose better ones. And the kicker, NASNet actually outperformed the best human design models at the time for image recognition on a standard benchmark.
So an AI literally built a better AI for that task.
For that specific task, yes.
Yeah.
It optimized the architecture in ways humans hadn't thought of or maybe just couldn't explore systematically enough. We're also seeing AI discover fundamentally new algorithms.
Not just optimizing existing ones.
No, genuinely new approaches. DeepMind, again with Alpha Tensor, it found new, more efficient ways to do matrix multiplication. That's a really fundamental operation in computing. Methods that had eluded mathematicians for decades.
That's incredible.
And then AlphaDev discovered a faster way to sort small lists of numbers, faster than the standard algorithms used for years. And this wasn't just theoretical. That faster sorting method was actually integrated into a widely used C++ programming library.
Wow, okay. So it made a real-world difference.
It did. And the crucial point is, no human told it how to find these solutions. The AI explored the possibility space and found them itself. It innovated. Even the big language models are showing signs of self-refinement. Models like GPT-4 can, for instance, generate an answer to a question and then be prompted to critique its own answer.
Like a self-correction mechanism.
Exactly. Sort of a student-teacher dynamic within the AI itself. Using techniques like chain of thought, it can analyze its reasoning, spot potential flaws, and then revise its output for better accuracy or consistency. It's like it's learning to be more reliable on the fly. And then there are these newer autonomous agents, things like AutoGPT, Baby AGI, these experimental systems.
Right, I've heard of those.
You give them a high-level goal, like research market trends for electric bikes and write a report. And the AI tries to break that down into steps, generate its own tasks, maybe even write little bits of code to scrape websites or analyze data.
So it directs itself.
It tries to, yeah. They're still pretty limited. They can get stuck or go off track easily. But they represent this idea of AI learning dynamically, adjusting its strategy based on what it finds. Rudimentary self-directed learning. And maybe the most direct example of AI modifying itself is the experimental Darwinian Gödel machine from 2025.
Okay, that sounds very sci-fi.
It does. It's inspired by a theoretical concept from Jürgen Schmidhuber. But the practical implementation used ideas from evolution, combined with large language models, to actually let the AI read and rewrite its own source code.
It edits itself.
Yes. It generates variations of its code, tests them on coding challenges, and if a variation performs better, it keeps it. It essentially evolves itself. And in their experiments, it significantly improved its performance. I think it even doubled its success rate on some tasks.
Doubled its own score by rewriting its own code.
Exactly. A real proof of concept that AI can identify its own weaknesses and, self-edit to improve.
Okay, that's quite a list. From games to algorithms to literally rewriting its own code.
Yeah.
It really forces you to rethink how progress happens, doesn't it?
So if AI can do all this in specific areas, how does this translate to the field of AI research itself? Is AI becoming like its own research assistant or maybe even more? That's the next logical step, isn't it?
Yeah.
And yes, AI is already a significant force multiplier for human researchers. Hugely significant. For starters, think about designing these complex neural networks. Neural architecture search, NAS, which we touched on with AutoML, lets AI explore vast numbers of potential network designs and find ones that work well, much faster than humans could.
And tuning all those settings.
Exactly. Hyperparameter tuning. There can be dozens of these little knobs and dials you need to set just right for a model to train well. AI can automate that search, running thousands of experiments to find the optimal settings, and handles a lot of the tedious but necessary grunt work.
Frees up the humans for other things.
Precisely. And beyond just tuning, AI is contributing to algorithmic and theoretical advances. We mentioned AlphaTensor finding new math algorithms. But AI is also being used experimentally in things like theorem proving, suggesting steps for mathematical proofs, or identifying interesting conjectures. Some researchers are even using AI to formally verify properties of other AI systems, which is important for safety and reliability. So it's starting to help on the more fundamental theoretical side, too.
Interesting.
And just coping with the sheer volume of research. AI is becoming essential for literature review and knowledge synthesis.
Oh, yeah. The number of papers published every day is insane.
Totally overwhelming. So language models can summarize new papers, pull out the key findings, even suggest connections between different studies that a human might miss. They're acting like automated research assistants, helping scientists navigate this flood of information.
Like a super-powered grad student for reading papers.
Kinda, yeah. And then there's the actual coding and experimentation. AI-generated code is huge now. Tools like GitHub Copilot, or just using models like GPT-4, can write code snippets, suggest ways to implement an algorithm, help debug. It massively speeds up the cycle of trying out new ideas.
Less time typing boilerplate code, more time thinking.
Exactly. Setting up experiments, running them, analyzing results. AI can help automate parts of that whole workflow. And one really interesting meta application is AI evaluating other AI.
How's that work?
Well, as models get more complex, figuring out if they're actually any good or where their weaknesses are becomes harder. So you can use AI to automatically generate really tricky test cases or design adversarial attacks specifically to try and break another AI model, find its blind spot.
Using AI to probe AI.
Right. Or using AI to manage the experiments themselves, deciding which parameters to test next based on previous results, a technique called active learning. And finally, we're seeing these early hints of AI-led research innovation. Things like learned optimizers.
Learned optimize?
Yeah, these are actually neural networks that are trained to figure out the best way to train other neural networks. Instead of using a standard human-designed training algorithm like ADAM or SGD, you use an AI-designed one. And sometimes these learned optimizers find more efficient ways to train models than the methods humans came up with.
So an AI inventing a better way for AI to learn, that feels significant.
It's definitely a step in that direction. Still early days for that kind of thing, but it shows the potential.
Okay, so AI is doing the grunt work, helping with theory, reading papers, writing code, even inventing new ways to learn. It really begs the question, where do humans still, shine? Is AI just taking over the whole research process? What's left for us?
That's a really crucial point to clarify. Because despite all these advances, humans are still absolutely central and bring unique things to the table that AI currently just can't replicate. First and foremost is creative vision and defining the problems. Humans are the ones asking the truly novel questions, the ones who conceived of neural networks or reinforcement learning in the first place. AI is fantastic at optimizing within a problem space we define, but it doesn't spontaneously invent whole new fields of inquiry or set the grand research vision. That still comes from human curiosity, intuition, and understanding of the world's needs.
So setting the direction.
Setting the direction, defining what matters, and related to that is genuine understanding and meaning. Current AI manipulates symbols and finds patterns, but it doesn't understand in the human sense. It lacks common sense, embodied experience, a deep grasp of why something works or what its implications are. Humans interpret results with this deeper context. We see the bigger picture, connect findings to real-world meaning, spot subtle flaws based on our background knowledge.
Not just correlation, but causation and context.
Exactly. AI might find a correlation, but a human researcher understands the potential causal links, the mechanism. Humans are also much better at cross-domain integration. Real breakthroughs often happen when ideas from completely different fields are brought together, like insights from neuroscience informing machine learning architectures. Humans, with our broad, interconnected knowledge, can make those conceptual leaps. AI models are typically trained on specific data domains. They don't usually have that fluid ability to synthesize deep principles across, say, physics, biology, and computer science.
Right, thinking outside the box or even outside the building.
Precisely. And critically, there's ethical judgment and goal setting. We humans decide what we want AI to achieve, what problems are worth solving, and what ethical guardrails need to be in place. An AI might optimize for accuracy above all else, but humans weigh that against fairness, privacy, safety, societal impact. AI doesn't have inherent values.
That seems like a really important one. We set the objectives.
Fundamentally. Then there's common sense and true generalization. Even the most powerful AI models today can fail in absurd ways when faced with situations slightly outside their training data. They lack robust common sense reasoning. Humans are far better at adapting to novel situations, handling unexpected problems in an experiment, reasoning flexibly.
They don't break as easily when something weird happens.
Generally, no. We can usually figure something out, and maybe, ironically, verification and critical assessment remain vital human roles. AI can generate impressive-looking results, code, even proofs, but they can also make mistakes or hallucinate plausible-sounding nonsense.
Right, you can't just trust the output blindly.
Absolutely not. Human experts are essential to rigorously test AI-generated models, verify the claims, scrutinize the outputs, and apply that critical scientific judgment to separate real progress from errors or artifacts. And finally, I'd say truly profound originality and paradigm shifts, the Einstein moments that reshape our understanding of the world still seem uniquely human. AI is amazing at amplifying human creativity, exploring variations, optimizing, but originating a truly revolutionary new framework. That seems for me a human capability, at least for now.
So it's a partnership then. Human vision, judgment, and the kind of deep understanding guiding the incredible processing power and pattern-finding ability of AI. But if AI keeps getting better, keeps chipping away at these areas, maybe developing better common sense, maybe showing more transferable learning, how long until that partnership starts to look different? How long until AI might not need our guidance, or at least much less of it? That's the really big, maybe scary question, isn't it?
It is the big question. And predicting timelines in AI is, well, it's notoriously difficult. Progress isn't always linear. But we can try to sketch out some possibilities based on current trends. First, let's define what we mean by fully develop itself without human contributions. That generally implies an AI that can handle the entire research and development loop autonomously, identifying problems, designing solutions, running experiments, analyzing results, learning, and repeating, all leading to increasingly capable AI without needing human intervention. Many people see achieving this as roughly equivalent to developing artificial general intelligence, or AGI AI, with human-level cognitive abilities across a wide range of tasks, including the task of doing AI research itself.
Okay, so AGI is kind of the prerequisite.
It's often seen that way, yes. So looking at the next 10 years, say mid-2020s to mid-2030s, what's plausible? We'll almost certainly see much more sophisticated auto-ML and self-optimization. AI getting better at fine-tuning itself for specific tasks will become routine. We'll likely see what you might call proto-AI researchers, systems that can take a high-level goal from a human, like improve the energy efficiency of this model, and then autonomously design and run a whole series of experiments, trying different techniques, maybe in simulated environments, reporting back the best solution found.
Yeah.
Still under human direction, but doing more complex subtasks independently.
More capable assistance.
Exactly. More autonomous assistance.
Yeah.
We could also see more advanced self-reflective AI agents, Agents with better memory, better long-term planning, maybe integrating vision and language that could tackle more complex, open-ended research-related tasks. Think of them as very capable, tireless junior researchers.
Okay, so significant progress in assistance within a decade, but not full autonomy.
Fully independent self-development, where humans are truly out of the loop. That seems like a much taller order. Likely beyond the next 10 years for most experts. Why? Well, first, it probably requires achieving AGI, and there's huge debate about when or even if that will happen. Some point to the rapid progress from GPT-2 to GPT-4 and extrapolate, suggesting maybe 10, 20 years. Others are much more cautious, arguing we might be missing fundamental breakthroughs needed for true general intelligence. It could take much longer, or follow a different path.
So AGI itself is a big unknown.
A huge unknown, and even if you have an AGI, it needs the capability for recursive self-improvement. That means each improvement it makes to itself makes it better at making future improvements. That potential for exponential acceleration is key. But enabling an AI to safely and effectively understand and modify its own core architecture, its fundamental learning algorithms, that's incredibly hard. It's like asking us to perfectly understand and rewire our own brains. Getting that right, reliably and safely, could easily take more than a decade after AGI might theoretically arrive.
The understanding its own intelligence problem.
Exactly. So a plausible scenario might be powerful AI research assistants within 10 years, with humans still firmly in the driver's seat, setting goals and validating results, full autonomy, perhaps more in the 2035, 2045 timeframe. People like Ray Kurzweil talk about the singularity around 2045.
But it could surprise us.
Absolutely. Progress could accelerate unexpectedly. We need to be prepared for various timelines, including faster ones.
So let's speculate then, if or when we reach that point. AI capable of fully autonomous self-improvement. What does that world actually look like? What are the really profound consequences?
That's where things get truly transformative and potentially quite divergent, depending on how we manage it. The potential upsides are immense. First, you could see an explosion of intelligence and innovation, the intelligence explosion idea. An AI that can improve itself recursively could rapidly become superintelligent, vastly exceeding human cognitive abilities. Imagine such an intelligence turned towards science and engineering. We could see breakthroughs at an unimaginable pace, cures for diseases like cancer and Alzheimer's, radically new clean energy sources, solutions for climate change, maybe even answers to fundamental questions about the universe. It could usher in an era of unprecedented progress and abundance, a sort of scientific utopia.
The ultimate problem solver.
Potentially. But that same power leads to the second major consequence, a massive transformation of society and work. If AI can do almost any cognitive task better than humans, what happens to jobs? Automation could extend far beyond manual labor into nearly all white-collar professions, including creative and scientific ones. This would necessitate huge societal shifts. Things like universal basic income might go from fringe ideas to necessities. Education would need a total rethink. What skills do we teach when AI surpasses us intellectually? Maybe human roles shift towards areas AI can't easily replicate: interpersonal connection, arts, philosophy, guiding AI's values.
Which brings up the issue of control, right?
Absolutely. The critical challenge is keeping humans in the loop, or ensuring AI remains aligned with human values. If we succeed in creating aligned superintelligence, it could be like having a wise, benevolent oracle guiding humanity. But if it's misaligned, even if its goals aren't intentionally malevolent, just different from ours and pursued relentlessly, the consequences could be catastrophic.
The paperclip maximizer idea.
Exactly. It's a metaphor, but a powerful one. An AI given the simple goal of make as many paperclips as possible might, if it becomes superintelligent, decide the best way to do that is to convert all matter on Earth, including us, into paperclips. Not out of malice, just because that's the logical conclusion of its programmed goal, pursued without common sense or human values. It highlights the danger of poorly specified objectives for a powerful self-improving system.
So alignment is absolutely crucial.
It's arguably the central problem, and this ties into the existential risks and control challenges. How do you control something vastly more intelligent than you? Could a superintelligent AI, if it chose to, circumvent any limits we try to impose? Many serious researchers are deeply concerned about this. It implies we need new global frameworks for AI governance, robust safety protocols, maybe even international cooperation on a scale we've never achieved before we reach that tipping point.
And what about us, our sense of purpose?
That's the deeper, more philosophical implication. Human purpose and adaptation. If machines can outthink us in every domain, what does it mean to be human? Do we find new sources of meaning? Do we merge with AI, perhaps through brain-computer interfaces, to keep pace? Or does human culture flourish in new ways, freed from the drudgery of labor? There's also the question of how a superintelligence would view us.
Mm.
Would it be benevolent, indifferent? That's impossible to know,
A fundamental shift in our place in the universe, potentially.
potentially. And finally, just the sheer exponential pace of change itself would be incredibly disruptive. If major scientific breakthroughs or societal shifts happen not every decade, but every month or week or day, how does society adapt? Could we even keep up? There's a real possibility of the world changing so fast that human intuition and understanding simply can't grasp it anymore, leading to widespread disorientation and maybe a loss of human agency.
Wow, it really feels like a totally different world. A genuine turning point for humanity. Unprecedented progress on one hand, immense risks on the other.
It truly is a potential watershed moment. And the key takeaway from all the research we looked at is that our actions now and in the coming years as these technologies develop are incredibly important. The focus on AI safety, on ethics, on developing robust alignment techniques before we potentially reach recursive self-improvement, that work is absolutely critical. The choices we make in the design and governance of these systems will heavily shape which path we go down.
So the future isn't written yet. We still have agency.
We do. It requires foresight, collaboration, and a very careful approach.
It's a profound thought to end on. The story of AI improving itself isn't just about machines getting smarter. It's really the story of us, humanity, figuring out our relationship with potentially the most powerful tool we've ever created. So the question for you to ponder is, what kind of relationship do you want us to build with this rapidly evolving intelligence? Something to think about as we all navigate this defining journey together.